Taylor series that we already know about. And I would like for us to first of all start with this series where it says find the Taylor series for f of x equals 1 over 1 plus x squared at x equals 0. So we have some options here. So let's talk about some of those options. What do you think you could do to create that series?
Take the derivative.
I could take a bunch of derivatives, evaluate those derivatives at 0, and just develop the series like we talked about at the end of that short little quiz. Yeah, I could definitely do that. So let's do a derivative or two and see if that's an option we want to take. So what is the derivative of this?
Negative 2x plus negative 2x plus x. Oh no, I'm sorry. Yeah.
I think if you use the other
negative
word
one.
besides
Yeah.
plus right here, you'd be good. How about
Yeah.
times 1 plus x squared to the negative 2 power. Now, for those of you that are not following along on that, this is like 1 plus x squared to the negative 1. Negative 1 comes down, that to the negative 2, and then Gabe put the 2x out front from the chain rule right away, which might have confused some of you. But there's a chain involved, right? And maybe after doing that one derivative, you're like, I want option B. But let's talk about one more derivative. Not only would you have the chain rule again, but you would have what? A product. Man, that gets complex fast. Because you'd have to use the product rule with this term and this term. Those derivatives would get complex. Maybe there's a better way. Let's see. Anyone else think of another way we could do this problem? What do you think? You would like to take this denominator and split it into what? Is that true? Yes. This is a true statement, right? If I boil that out. Or is it? It'd be 1 minus x squared. Oh, so close. Okay. Anyone else have any thoughts? Good thoughts so far? Yeah. No dumb. Woo! Integrating. You want to integrate that? Why not? Do we know the antiderivative of that? What is it? Something trig? What is it? Oh, come on, Lauren.
Pretended and Harris is wrong.
I've already pretended I didn't.
Is it something natural log? Because natural log is like derivative 1 over x.
This is me pretending I didn't hear. It is arctangent. That is true. It is arctangent, and if I integrated, I would get arctangent. Do we know a series for arctangent? We do? You know some trig identities for sure, yeah. Hold that thought. Okay? Now, does this thing look like one that we know? Like one of the 4 we've memorized? Is it kind of like one of those? Which one?
1 over 1 minus.
1 over 1 minus x. Except, I got some different things there. So how could I take this, which we know, and make it into this, which we want? If I just square it, then I'm going to be not where I want to be. Could I put something in place of the x to get me here? This is 1 over 1 minus x with what in place of the x? Negative x squared. If I were to take this 1 over 1 minus x, and instead of that x, I'm going to put a negative x squared, wouldn't I get this? The series I want. So I could take the 1 over 1 minus x, which we know, what is that? 1 plus x squared plus x cubed plus blah, 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 x to the n. And in place of the x, I could put negative x squared. Would you get that series? For sure you would. So let's do that. So in place of this x, I'm going to put a negative x squared. I'm going to actually write it that way. Equals, and if I put that in place of the x over there, what do you think I have to put in place of the x here? Great, so let's do that. 1 plus a negative x squared plus a negative x squared squared plus a negative x squared cubed plus dot, 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 dot. And I put a negative x squared in place of the x there. That is the correct series. And in essence, what did we do? What fancy word did we call that? We substituted. We put something in place of something else to come up with what we wanted. And that becomes the series for 1 over 1 plus x squared, which is 1. Next term, minus x squared plus x to the 4th minus x to the 6th. So it alternates because we're raising a negative to an even and odd power plus dot, dot, dot. And this would be general term, negative to the n, so negative 1 to the n. That's the alternating part. X to the 2n. That's that series. We used a series that we already knew about, and we did a substitution to find a series that we wanted. Yeah? Yeah. Do another one. I would like for you to find the Taylor series for g of x equals e to the 7x. There you go. Just for fun, I'm going to make it more complicated. 7x squared. I would hate for you to want to actually take derivatives. So let's try that. Oh, that's I wouldn't say that. Check your answer with someone around you. By doing this, I would say I only want the first like 3 or 4 non-zero terms, and then the general term would be great.
Oh, yeah.
Okay, what'd you do with this e to the x that you already know about? Put a 7x squared in place of the x. So e to the 7x squared is going to equal 1 plus 7x squared plus 7x squared squared over 2 factorial plus 7x cubed over 3 factorial plus dot, 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 7x squared to the n over n factorial. That'd be a great answer. Let's go even further. Let's simplify this. E to the 7x squared equals 1 plus 7x squared plus over 2 plus, if I do 7 cubed, 343 over 3 factorial 6, so that'd be x to the 6th, right? And then you could keep on going. I don't think 6 goes in 343. And then this would be, as a general term, what would it be? Seven in. 7 to the n. X to the 2n over n factorial. Something that is quite complex that if you started taking derivatives, you would not want to. Because if I had to get to the first 4 non-zero terms, how many derivatives would you have to do? You'd have to get to the 6th power. You have to do 6 derivatives because there are some non-zero terms in there. That wouldn't be fun. At least for you. All right. Now, how about this? Find the Taylor series for f of x equals 1 over 1 minus x quantity squared at x equals 0. Yes, Lauren.
Going back to the second, or the one we just did, why didn't we do the step where it was like, we found out what to put into x to make it the same as the, like, 1 now, which would just be x, or even the,
Make you feel better?
yeah.
Okay. Yeah, I mean, you don't have to write that out. But I just know that e to the x is this, and you should as well. So if that's e to the x, e to the 7x squared would just be this with the x replaced with the 7x. If you want to write that down, by all means do that. All right, let's go to this one. 1 over quantity 1 minus x squared. Clearly, that one looks like which one? 1 over 1 minus x, which is really, really nice. It's a very nice series for us to look at. How are those two related? Squared. Yeah, this squared is equal to 1 over 1 minus x squared. True? All right. So, ready to infinitely FOIL? Okay. That means that I've got 1 plus x squared plus x cubed plus forever times 1 plus x squared plus x cubed forever. Yay. You're going to be busy for a little bit. Okay? But we could think our way through this. Me? Or you? We can think our way through this. Constant term. The term that has no x's with it. What's the only thing that we get when I multiply this out infinitely that is just going to have a constant? 1. And that 1 is from the 1 times the 1 right there. Fantastic. You're well on your way. All right. What is the x term? How do I get x's? This 1 times that x, but I could also take this 1 times that x. So how many x's? I got 2 of them. It's looking fun. So what's the next one? Yeah, how many? 1 of them? Well, let's talk about it. How do I get x squareds? I could get an x squared from this 1 and that x squared. I could get an x squared from this 1 and this x squared. How else could I get an x squared? This x times this x. Any others? It looks like I got 3 of those. Man, this can get complicated if I keep doing this. There's got to be a thing. An infinitely foiling. How are these two things related? Any other relationship besides squaring? True and true. Ish. This is a rational function degree 1. This is a rational function degree 2. Or, sorry. No. Whatever. You get it. Oh! How do I go from something that is 1 minus x to the negative 1 power and get to something that was 1 minus x to the negative 2 power? It's the derivative. The derivative of this is that. So if I differentiate this, the negative 1 comes down, I get that to the negative 2, but I got a negative on the inside of the chain rule to make it positive. So if that's the derivative, then I could just take this series we know, 1 plus x squared plus x cubed plus x to the n, and I could differentiate each term. I could ddx this, and I could ddx this. I could take infinite derivatives. 1 over 1 minus x squared is equal to what? Oops. First term. What happens to the derivative of that 1? 0. Derivative of that? Derivative of that? Hey, look. Derivative of this? Let's do one more. How many x to the thirds would you have? You'd have 4 of them. Boom, 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 boom. 2. What's the general term? N x to the n minus 1. That's the power rule. Because each of these are polynomials or power functions. Well, that's fun. So not only were we able to, first of all, do what to get a new power series? Substitute. We now can differentiate ones that we already know. But let's talk through that. Which ones do we know and need to memorize? Sine. Oh, sine. What's the derivative of sine? You already know that. What's the derivative of cosine? You already know sine. Just put a negative in front of the terms. E to the x, what's the derivative? Really, that's the only one we need to worry about. Okay. This one. Okay? What do you think the third thing is? Substitution, derivatives, integration. So, find the Taylor series for f of x equals arctan of x at x equals 0. Now, we come back to what was said earlier, that arctangent is the antiderivative of what? Integral. The integral of 1 over 1 plus x squared, which is one we already did today, is equal to arctan plus a constant. We'll get to that constant in a little bit. So 1 over 1 plus x squared was a derivation of 1 over 1 minus x that we already did. So let's just copy that and paste it in there. And you can rewrite it while I'm doing that. Well, I missed. Yeah. No, we're doing this. I wrote up words. Oh. Copy that. I can just remove it. That's that. And that's the series. So, if I know that this is 1 over 1 plus x squared, I could integrate dx infinitely. And that would mean arctangent of x is equal to what? Double what?
1
1, thank you, Bryce. I'm saying that again. 1/3 x cubed. I did? No. Okay, 1 times 1. 1/5 x to the 5th minus 1/7 x to the 7th plus blah, 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 blah. I'll let you figure out the general term. You could do some work on that. Anyways, there's always that plus c at the end of the integration. And we were told this is centered at x equals 0. What's the arctangent of 0, or what angle gives us a tangent of 0? 0. So therefore, add 0 to that, and there you go. That's it. And if you differentiated that, you would get that one. So the 3 things that you could do to develop new Taylor series from known Taylor series is substitute that's the big one. Then you might also want to differentiate. And you could also maybe integrate. Substitution is the one that shows up the most.